We're looking at the solutions to your exam that you just took during class. You are going to go through and you're going to grade your exam, and then you're going to upload your solutions to Canvas. And so looking at this, the following example says solve x squared over x squared minus 1 minus 4 all over the quantity x plus 1 equals 4 all over the quantity x plus 1 times the quantity x minus 1. So looking at this, we want to factor all of our denominators. I see that this x squared minus 1 is a difference of squares, and so this factors as x minus 1, x plus 1. Because this is an equation, we can get rid of our fractions by multiplying through by our least common denominator of all the fractions within the equation. We want to multiply everything through by our LCD. Our least common denominator is x minus 1 all times x plus 1. So multiplying both sides and every single term or grouping by this x minus 1, x plus 1, when we distribute it on the left-hand side of the equation to this x squared all over x squared minus 1, the x minus 1, x plus 1's cancel, just leaving us with a numerator of x squared. Minus, when we distribute the x minus 1, x plus 1 to the 4 all over x plus 1, the x plus 1's cancel, and we're left with a 4 all times the remaining factor of x minus 1. This is equal to, now let's distribute the x minus 1, x plus 1 to the 4 all over x plus 1, x minus 1. Those cancel, leaving us with just 4. So let's distribute. I see this is a quadratic equation, and so we're going to get everything to one side of the equation. We have x squared distributing our negative 4 to x minus 1. We get negative 4x plus 4, and that this is equal to 4. So let's get everything again to one side of the equation. We can subtract 4 on both sides, and I notice that is going to cancel with a positive 4 on the other side, and so this is equal to 0. I'm going to solve this by factoring. I notice that both of them have a factor of x, and so pulling out an x, we get x times the quantity x minus 4. Set each factor equal to 0, we get x equals 0, and when x minus 4 is equal to 0, we get x is equal to 4. This problem, you had variables in the denominator of this rational equation. You had to make sure that x did not equal values which made our denominator equal to 0. So x couldn't be 1 and x can't be negative 1. If you look at our solutions though, x is neither 1 or negative 1. And so we have two solutions to this rational equation. We get x equals 0 and x equals 4. This problem is worth 5 points. Give yourself credit if you got everything correct and you showed your work in a nice and organized manner. If you didn't get the correct answer, but you had gotten maybe a sign off, or it just, just a little teeny error, maybe knock off a half a point to a point. If you are missing some concepts, then you're going to deduct more points from that 5 points. I normally, when I'm grading, I will put my score all over how many points for that problem it was worth. So in my case, I got it totally correct, so I would show 5 over 5. Okay, so let's look at the next problem. The next problem, we have a square root of 3, and then underneath that radical, we still have the square root of 2x minus 1. And then outside of that radical, within the main radical, but inside that main radical, we have plus x, and then it's all equal to 2. So when we're solving radical equations, you want to get the radical, or one of the radicals, to one side of the equation and get everything else to the other side of the equation. Well, that's already done for us. And then we want to raise both sides of our equation to a power that will get rid of the radical. And so because this is a square root, we're going to square both sides of our equation. So that's going to get rid of my main radical, leaving me with 3 square roots of 2x minus 1 plus x equals 2 squared, which is 4. Okay, so again, I still have a radical in here, so I'm going to want to go through and I'm going to want to isolate my radical. So I have 3 square roots of 2x minus 1 equals 4 minus x. I could divide both sides by 3, but in this case I really don't want to deal with fractions, and so I'm going to leave it there and use my rules of exponents, because it's multiplication between the 3 and the square root of 2x minus 1. I can square each piece. And so if I square my 3, I will get 9 here, all times the square root of 2x minus 1 quantity squared. That's just going to leave us with what's underneath the radical, which is called the radicand, 2x minus 1. And this is equal to 4 minus x quantity squared. So I'm going to rewrite that as 4 minus x times 4 minus x. We want to go through and we want to simplify down each side of the equation. So let's distribute our 9. So we have 9 times 2x is 18x, minus 9 times 1, which is 9, is equal to, so if I distribute this out, 4 times 4 is 16, and my two middle terms, a negative 4x and a times a negative, or plus a negative 4x is a negative 8x, and then negative x times negative x gives us plus x squared. After distributing and simplifying both sides of the equation, you should notice it's a quadratic equation, and most times that we solve quadratics, we get everything to one side of the equation. So let's subtract 18x and then add 9 to both sides of the equation. So doing that, we get x squared. So we're going to have a negative 8x minus 18x. That's going to give us minus 26x. And then we have 16 plus 9, which gives us plus 25. This is equal to 0. I notice this is factorable, so I'm going to solve it by factoring. Factoring x squared minus 26x plus 25, the two numbers that multiply to 25 and add to negative 26 is negative 25 and negative 1. So we can factor this as x minus 25 all times x minus 1 equals 0. Setting each factor equal to 0, we get x is equal to 25, and we get x is equal to 1. If you ever raise both sides of your equation by an even power, then you need to check your solutions, your answers at the end of your solutions, to see that they actually work. And so let's check this. We're going to go back in, and wherever we see an x in our original equation, we are going to plug in, let's do x equals 25 first. So doing that, I'm just going to go in, and wherever I see an x, I'm going to put in a parentheses, and then inside the parentheses, I'll replace it with what I am evaluating this at. So I have square root of 3, and then times, underneath that radical, the square root of 2. I see an x, I'm going to replace a parentheses, minus 1. And then outside of that radical within, I have plus x, so I'm going to put a parentheses, equals, we want to know, is this equal to 2? So let's go back in and replace inside that parentheses with 25. We're going to use order of operations to simplify the left-hand side of the equation. And so we have the square root of 3 all times, well, 2 times 25, that's 50, 50 minus 1. So we get the square root of 49, and then plus 25. We're asking ourselves, does this really equal 2? Well, the square root of 49 is 7, so we have 3 times 7 underneath this main radical, which is 21, plus 25. Is this equal to 2? And right now I can see that the square root of 46 does not equal 2. And so x equals 25 is not part of our solution set, and so we're going to exclude it from our solution. So let's now go in and plug in x equals 1 wherever we see an x in our original equation. And if we do that, we get the square root of 3 all times the square root of 2 times 1 minus 1 plus, put parentheses wherever we see an x, plus, we're going to have 1. Does this equal 2? So simplifying this using order of operations, we have the square root of 3 all over. So square root of 2 minus 1, that gives me the square root of 1, which is 1. And 1 times 3 is this 3, plus 1. Does this equal 2? And I can see that that is equal to 2. Square root of 4 is equal to 2. And so this is correct. And so we have one solution to this equation, and that would be x equals 1. This problem is also worth 5 points. Go through and determine how many points you feel you should get based off of that. If you have gotten everything correct, and then you're going to give yourself 5 points. Make sure that you had checked your solutions. If you didn't check your solution, knock off about a point. So question 2 has a lot of information in it, lots of different parts. So let's go through number 2. Number 2 says if f of x is equal to x squared minus 3x minus 4, answer the following question. Write f of x in vertex form. So there's many different ways that we can write this in vertex form. One way is to complete the square. But I notice if I complete the square here, I have my b value. When I look at half of that, I have to deal with a fraction or a decimal. And so I really don't want to do that. I guess it really doesn't matter either way. Or I can use the fact that the vertex formula says that my x value of my vertex, which we call h, is equal to negative b over 2 times a. Well, my b value is negative 3, and so this would give me 3 all over 2 times a, which is 1, is 2. My k value of my vertex, which is also the y value of the point of your vertex, and this is equal to f of negative b over 2a. So I need to go in here and I need to plug in 3/2 wherever I see an x in my original function f of x. Let's solve this over here. So I have f of 3/2 is equal to, wherever I see an x here, I'm going to just put parentheses. So I have 3/2 quantity squared minus 3 all times x, so put parentheses, minus 4. Okay, so again, putting in 3/2 wherever we see an x and simplifying. So 3/2 times 3/2, that's 9/4, minus 3 times 3/2, this is 9/2. I notice that I'm going to have to get a common denominator when I simplify this, so let's just put this times 2 over 2. Minus 4. And I notice also I'm going to need a common denominator, so let's rewrite that. And multiply that 4 by 4 over 4. So simplifying this down, we have 9/4 minus 18/4 minus 16/4. So 9 minus 18, that's negative 9, and negative 9 minus 16, this is negative 25/4. Okay. You can leave it like this, or if you want to, and it's going to be easier when we plot this, that 3/2 is 1.5 and negative 25/4. Well, 4 goes into negative 25 and negative 6 times, and 1/4, which is 0.25. So our vertex f of x is equal to our a value, all times x minus h, quantity squared, plus k. That's the vertex form. And so we wanted to write our equation in this form, so we have f of x is equal to a, which is 1 in our case, x minus h, so this will be x minus 1.5 or 3/2 or 1 1/2, depending on how you wrote it, plus k, so minus 6.25. Our vertex, which we had found above, is 1.5, negative 6.25. And it wanted to know, is this a max or a min? Well, that determines if our value of a in front of the number in front of x squared is positive or negative. Our value of a is 1. This is greater than 0, which tells me my parabola faces the original direction upwards. And so if my parabola faces upwards, then I know that this is a minimum point. At what point in the graph do we cross the y-axis? So our y-intercept, if we look at our original equation of f of x, we are going to plug in 0 wherever we see an x. And if we plug in 0 wherever we see an x, this is going to give us back negative 4. So we have a y-intercept at our point 0, negative 4. What is the point symmetrical to the y-intercept? Well, I'm going to come back to that one. It helps me when I graph it. And then what are the x-intercepts? Write your point, answer as a point. If they do not exist, explain why. So we talked about locating where our vertex was, and if it was going up or down, depending on what quadrant we were in, depends on if we would have an x-intercept or not. So if we plotted our vertex 1.5, negative 6.25. So 1.5, and we're just going to estimate, so that's going to be about right here. We know it's facing upward, so I know that it's going to cross. We also know that we have a point at 0, negative 4. This is where I can look at, that's helpful, where my point is symmetrical across this line. And we know that at 1.5, x equals 1.5, this is where we have our axis of symmetry. And so I know it's an even distance here, which is 1.5. My x value is going to, my y value is going to be at 4, but I need 1.5 from 1.5, so it's going to be at 3, negative 4. Now let's find our x-intercepts. We can go back here, and if we can, we could factor it, or we can use the square root method. I notice that this is factorable, so f of x, our y value is 0, equals, so factoring x squared minus 3x minus 4, we have x minus 4 all times x plus 1. Set each factor equal to 0, we get x is 4, and we get x is equal to negative 1. Our axis of symmetry is the vertical line that goes through our vertex. So this is x is equal to 1.5 or 3/2. Make sure it's in the form of x equals and not just the number, because this is an equation. What is the range? The range, we're looking at all the y values that we're hitting on this graph. The smallest y value that we hit on this graph is the y value of our vertex, because this is going upwards. And so the smallest y value that we're hitting is this 6.25, negative 6.25. And so we're including that, so we're going to put a bracket. This asks me to put it in interval notation. And so we have negative 6.25, and then we're hitting all the y values that go up to infinity. Where is the graph increasing and decreasing? Again, this asks me to put it in interval notation. It is increasing when we are at the vertex, right? And we're starting to go up on the left or right of our vertex. And so we look at our x value. The x value of our vertex was 1.5. And so we have 1.5 to infinity. It's decreasing, it's going downwards, and we're looking at our x values. So our x values from negative infinity until we hit 1.5. The last question wants to know when f of x is greater than 0, we can either use the graph that we just made, or we can solve this algebraically. Well, we just did all the work, pretty much, by graphing it. Notice our x-intercepts are x equals 4 and x equals negative 1. I notice that this is above the x-axis. It's bigger than 0. For values coming in from negative infinity until I hit this x value, which was negative 1. So it's greater than 0 from negative infinity to negative 1, union. So it's also bigger than 0, our y value, when we have our x value starting at 4 but not including, so a parentheses, 4 to infinity. Okay, so this problem had a lot of different parts. And let me give you the points for each part, and then you can determine how many points you feel you got for each equation. So this first part A, this is worth 4 points. Part B is worth 2 points. C is worth 2 points. D is worth 2 points. E is worth 3 points. F is worth 3 points. G is worth 2 points. H is worth 2 points. I is worth 4 points, but that's 2 points each for where is it increasing, that's worth 2 points. Where is it decreasing is worth 2 points. And then J is worth 3 points. So altogether, this second problem was worth 27 points. Let's move on to the next problem. Okay, so the next problem we're given says the different quotients is the average rate of change between 2 points, x, f of x, and x plus h, f of x plus h, on the curve f of x. Show the slope of the line between these 2 points that I just gave you is the different quotient, which is the numerator f of x plus h, and then minus f of x. That whole quantity I gave you is all over h. Okay, so let's apply the slope. So we know that the slope is equal to the change in y. So our change in our y value, if we look at the first value, f of x plus h, minus our other y value, which is f of x, all over the change in our x value. So we started with the second point that was listed, so we need to start with the x value of the second point that's listed. So we have x plus h minus this value of x. Let's just simplify. Can't simplify anything in my numerator, so I have f of x plus h minus f of x. But my denominator, notice we have an x minus an x, and so those cancel, and so this is all over h. Now it tells me if f of x equals x squared minus 2x, find the difference quotient of f of x and simplify your answer. So we're going to go in and we're going to plug in x plus h first, wherever we see an x. I think it's helpful if we go in here first. I'm going to plug it over here. And plug in parentheses wherever we see an x in our function f of x. So we have an x squared, so we have a parentheses squared. Minus 2 times x, so we have minus 2 times a parentheses. Now let's go in there and plug in x plus h. wherever we have those parentheses. Okay, so that's the first piece of our difference quotient, this f of x plus h. Then it tells us to subtract off our f of x value. So minus f of x. Well, our f of x value is this x squared minus 2x. It's more than one term, so I need parentheses around this. So x squared minus 2x. Then it tells me to put this all over h. Okay, so we want to go through and we want to simplify this. And so we want to expand out x plus h quantity squared. And so this is x plus h times x plus h. This is a little bit of side work. And if you distribute that out, you get x squared. You're going to get a hx times an hx. So that's a plus 2hx. And then an h times an h is plus an h squared. So that's just our x plus h quantity squared. And now let's distribute our negative 2 inside the parentheses of x plus h. So distributing our negative 2, we get negative 2x minus 2h. And now let's distribute the negative outside of x squared minus 2x. And if we do that, we get minus x squared plus 2x all over h. Start simplifying. Things should be falling out in our numerator, and they are. So notice we have a positive x squared minus an x squared cancels. We have a 2x and a negative 2x, so those cancel. Every single term that we're left with in our numerator, we have an h value, 2hx plus h squared minus 2h all over h. So let's factor out the h in our numerator and cancel it with our h in our denominator. So if we factor out that h, or divide every single term by h, you can see that too. So 2hx over h, that's just giving us 2x, plus h squared over h, that's just a single h, minus 2h over h just leaves us with a 2. So we found our difference quotient. Which is 2x plus h minus 2. In this problem, each piece is worth 5 points. So go ahead and grade that. So going to problem 4. Problem 4. If f of x is an odd function, then by definition, what do we know about f of x? Well, if f of x is an odd function, then we know that if we plug in negative x wherever we see an x, this would be the same thing as negative f of x. So that's what I was looking for, and that's 4 points. You could have added some more information. And I might have given some partial credit there. We know that odd functions, these are symmetrical across the origin. The way we tested for symmetry across the origin, or if it was odd, wherever we had an xy point on our graph, we also have the point negative x, negative y. That's also solution. That is going to help us with the next part, or next problem, 5. The following graph is odd. Complete the graph. Okay, so let's just find some values, knowing this right here that I just said, if xy is a point, then we also know negative x, negative y is a point. So let's locate a point on the graph. So 1, 2, 3, 4. So this is a point at negative 5, 0. If I change the signs on both of my x and y values, I just get back 5, 0. So I have a point here. I have a point that is at 0, 0. Well, changing the sign of 0, 0 doesn't do anything. That's still just 0, 0. Let's look at this max value. And so this is 1, 2, 3, negative 3, 3. Changing my values on that point, though, gives me 3, negative 3. Which is here. And so we finished the graph of that odd function. And if you did it correctly, this is worth 4 points. Moving on to our next problem. So the next problem has multiple parts, and it's a piecewise function. Okay, so looking at our piecewise function, we want to graph each piece and we want to look at the domain that we're graphing. And so our first equation is 2x plus 4 if x is less than negative 2. Recall that when we were graphing these that we wanted to see what was happening at the end value of our inequality. And so looking at this equation, 2x plus 4, which you should know is a line, let's see what's happening when x is negative 2. And if we plug that value in wherever we see an x in that first equation, we get 2 times negative 2, which is negative 4, plus that 4, which gives us back 0. I'm going to put a little note to myself, or maybe I should just go graph it. We have an open circle at this point, negative 2, 0, because this was strictly less than negative 2. So now when I choose values for my point for that first equation, they have to be less than negative 2. So negative 3 is less than negative 2. And so 2 times negative 3 is negative 6 plus my 4. That gives me negative 2. So negative 3, I have a point at negative 2. Again, I know that this is a line, so it's going to extend down like this. So let's go through and let's graph the second equation. And so our second equation, we have 2 bounds of our inequality. The left-hand bound, negative 2, is less than or equal to x, so that's going to be a solid circle. And then x is less than 1, so we need to see what's happening at 1 also, and that's going to be an open circle because that's strictly less than. And so let's plot some points. I know that that's also a quadratic equation, so it should look like a parabola, but I'm not sure where the vertex is, so it might not just have both of that. It might not have the vertex. So it might not kind of look just like a parabola. Anyways, so plugging in negative 2 wherever I see an x, first I square my negative 2, which is 4. Then I have this negative out front. And so that's going to be positive 4 minus 2, which is 2. So again, I told you that that was a closed circle. So let's go to negative 2. X is negative 2. Our y value is 2. Closed circle. And then let's see what's happening when x is 0. If I plug in 0 for x, we get 0 squared, which is 0 times negative 1 is 0, minus 2 is negative 2. So we have a point at 0, negative 2. Did I do something wrong? I did. When I plug in negative 2, I square it, it's 4. 4 times negative 2, 4 times negative 1 is negative 4, minus 4 is negative 6. This first problem, it should be negative 6. Okay, that makes sense. So at x equals negative 2, we have y equals negative 6. I knew something was wrong because I knew my parabola should be facing downwards because I have a negative x squared. We also should know because of our transformations of graphs that is our vertex is at 0, negative 2. That was a solid circle. So it kind of comes up like this. And then let's look at what's happening at 1, but I know that's an open circle. So 1 squared is 1 times a negative in front, which is -1, minus 2 is -3. So x equals 1, we have y is -3 with an open circle. So the last graph is y equals -3. And so with that, we know it's a horizontal line, and it's a horizontal line going through -3 if that was our x value. But our x value that we're starting at is at 1. So at 1, we have a point at -3, which fills in this open circle and makes it now solid. And this is for every value of x, which is greater than or equal to 1. If you look at the range, these are all the y values that you're hitting. And this graph here, that first graph that we were plotting, that's going to go down forever. And so we're hitting all the y values from -infinity. And then it looks like the smallest y value, but we're not including it, is 0 because of the open circle. Where is the graph decreasing? So if we're looking at this going from left to right, it's going down from left to right when my x values, you always use x values, is 0. And then it stops at 1. Going left to right, where is the graph increasing? And so looking at the x values, I'm coming in my x values from -infinity, and then I'm stopping when x is -2, parentheses. Union, it's starting here again at -2, it's going up, and stopping at 0. Where's the graph constant? That's where our graph is horizontal. And so looking at our x values again, it's horizontal starting at 1 and going to infinity. Find g of -2. So g of -2, so that's asking me when x is -2, what is my y value? Notice that x equals -2, that's where we're changing equations. And so we want to look at the equation that includes -2, and that's going to be the second equation. So if we square -2, that's 4 with a negative in front, that's -4 minus 2. And so that's going to give us back -6. In this problem, we have multiple points, different points. So the first piece, the graph, is worth 6 points. So I was thinking that like 2 points per each piece of the graph if you got that piece correct. And then all the other pieces is worth 2 points. So B is 2 points, C is worth 2 points, D is worth 2 points, E is worth 2 points, etc. And so we have 2, 4, 6, 8, 10. We have 16 points for 6. So go through and score each piece and then put your grade there. Number 7, we're trying to find the domain of the following. The square root of f of x equals, we're trying to find the domain of f of x equals the square root of 4 minus 8x, all over x squared minus 9. So looking for the domain, we're looking for our trouble spots. We know that what's underneath the radical, which is 4 minus 8x, this needs to be greater than or equal to 0 because it's in the numerator. So let's solve for x here. Let's subtract 4 on both sides. We get negative 8x has to be greater than or equal to negative 4. And then let's divide through by negative 8. But recall when you divide by a negative, that flips our sign. And so we get x is less than or equal to negative 4 divided by negative 8 reduces to 1/2. So x has to be less than or equal to 1/2, and we have a problem if we have variables that set our denominator equal to 0. And so we want to factor x squared minus 9, which is a difference of squares, so this factors as x minus 3, x plus 3. And we're looking at values which set it equal to 0, and we need to exclude those. So x minus 3 is equal to 0 when x is 3, so x can't be 3, and x plus 3 is equal to 0 when x is negative 3, so x can't be negative 3. If you're looking at the solution set, well, it's everything that's less than 1/2 or equal to, so a bracket, right? But that other piece said that x can't be 3 or negative 3, and so we can't have a point here at x equals negative 3. X equals 3 is not part of that x is less than or equal to 1/2. And so I really need this open circle in here. So I can have everything shaded that is bigger than negative 3 up to 1/2 and including, and I can have everything shaded to the left of negative 3 but not including. And so if I wrote this in interval notation, I have negative infinity to negative 3, parentheses, not including that negative 3, union, parentheses, negative 3, comma, and we're going to 1/2 and we're including it, so bracket. This problem is worth 5 points. Looking at the next problem, we're looking at this problem and determining transformations of the graph. And so the first part says, the function f of x and g of x are graphed on the same Cartesian coordinate plane. F of x is equal to the absolute value of x and is the graph that is solid. And the graph of g of x is that dotted line. So list the transformations that are being performed on the graph of f of x to get the graph of g of x. In other words, what, if any, horizontal translations, vertical translations, reflections, shrinking, or stretching are you doing to the graph of f of x to get the graph of g of x? Okay, so let's look at the vertex here of our original function, square root of x. Our parent function is what we were calling it. Let's look at the horizontal shift to get to this vertical. And so notice that we're going over 1, 2, 3 units to the left. So we're shifting f of x to the left 3 units. And so let's think about how we would write that. Well, if I was looking at my f of x function and I was shifting it to the left 3 units, it's going to be inside of the absolute values or inside the parentheses of f of, and it was the opposite. So this is going to be an x plus 3 in here. Okay, so that's our horizontal shift. Let's talk about reflection now. Notice that we have a V shape that is facing upwards, and now our V shape is facing downwards. And so that tells me that the value of my y is changing. My value of my y is changing. This is a reflection across the x-axis. And what that's going to do is that's going to put a negative in front of my f of x value. I'm just going to leave what I had before, f of x plus 3. But technically, if I did what I just did, that would give me this piece right here. And now we want to shift this up. And so I have to see how many units am I shifting this up. So it's 1, 2, 3 to get to this vertex. And so vertically shifting up 3 units. And so if we're shifting it up 3 units, we're going to add 3 outside of our f of x value. And so in our case, so far we have negative with all those 3 transformations, f of x plus 3, and then outside of that plus 3. The only thing else I'm kind of worried about is this stretching or shrinking. It doesn't look like it, but let's just look at kind of a in here, like here, this is symmetrical across the x-axis, right? And so in here, this distance is 1. Let's look over here, between here. This distance, well, not 1, it's 2, and this distance is 2, same distance. So it looks like it's no vertical stretching or shrinking. Okay, so we listed all the transformations that were done with that graph, and that piece is worth 4 points. Part B is going to ask us to find the equation of g of x applying those transformations. And so this is why I wrote it this way, because this is going to help us. And so if we go into the absolute value of x and we plug in x plus 3 wherever we see an x, we get the absolute value of x plus 3. Then we're putting the negative outside of the absolute value to reflect it across the x-axis. And then we're shifting it up 3 units. So we're adding this 3. So we now have our equation of g of x, negative absolute value of x plus 3 outside the absolute value plus 3. This also was worth 4 points. Going to problem 9. So problem 9 says z equals a plus bi, w is equal to c plus di. Show that the z times w bar of that product is equal to z bar and then times w bar. And recall that the z bar is a conjugate of z. Okay, so let's first look at this left-hand side. So let's work on the left-hand side. And we're going to manipulate this side to look like the right-hand side. And so z, we know, is a plus bi. And w is c plus di. And we're looking at the conjugate of that. So let's perform the operation underneath this bar. And so if we distribute a times c, this is ac. A times di, so this is plus a di. bi times c, so this is plus bci. And then bi times di. So that's bdi squared, but recall I squared is negative 1. So this is going to be minus bd. So let's go and group our real parts together. So our real parts are the parts without the I in it. And so we have AC minus BD. That, and then if we group our imaginary parts together, let's pull out the I. So this is going to give us plus. So pulling out the I from our AD plus BC. We're going to plot our I. And we still have that bar over everything. Well, the conjugate, what is that saying? Or this bar is telling me to take the conjugate. So that's telling me to change the sign between my real part and my imaginary part. And so if I do that, I can drop that horizontal line above, and that's going to give me this AC minus BD. Now it's going to be minus the imaginary part, which was AD plus BC in parentheses times I. It's not quite in the form that I can see that this is Z bar times W bar. And so let's distribute our I, and then let's regroup things. And so if we distribute our I to the AD plus BC, and let's just drop our parentheses for the first parentheses. So we have AC minus BD, and then let's distribute actually negative I. So negative I times AD, so this is minus ADI. And then negative I times BC is negative BCI. So we're trying to get, kind of going back and looking at what you're trying to prove, Z with a bar over that. And so I know Z with a bar over it is going to be A minus BI. And so I'm kind of trying to manipulate that. So maybe regrouping. So we have, let me see, is that the best way to go? Well, let's just do it. Sometimes you're just not sure if you're going in the correct way, and you just got to try, right? So let's redo this. So let's, and I'm trying to get it so with that it's A plus BI, BI. Now let's regroup it with, this is what we're going to regroup with. Okay, so we have AC minus BCI. And then let's group the other two, negative BD minus ADI. And so we could factor out a C here. We could factor out a D there, negative D. Yeah, that's not working. I don't see that working. Well, if we plot a C, we have A minus BI times C. If we pull out a, let's just see, if we pull out a negative D here, then we would be left with a B minus AI plus AI. So something's off. Okay, so that's another way to look at this. So let's say maybe let's stop here. So that's our left-hand side. Let's work with our right-hand side for a little bit. And I'm going to leave that there because I might want to come back to it. Okay, so looking at the right-hand side, if we look at Z bar times W bar, well, this is equal to A minus BI and C minus DI. And so if we distribute, we get a times c is ac, a times negative di is negative ADI, negative bi times c is negative bi or bci, and negative bi times negative di. Well, negative times negative is positive, but we have an I squared, so that's negative. And so this is going to be a minus BD. Regrouping our real terms. So AC minus BD equals, and let's factor out an I, negative I. It's not equals. I'm going to put parentheses around that. And pulling out a negative, I'm going to put the I out front, or out back. So doing that, I have negative, pulling it out, negative I from negative ADI, that gives me AD. And pulling out a negative I from BCI, that gives me plus BC. Which is exactly the same thing as where I told us that we should maybe just go back and stop there. Okay, so we probably should have been able to work on just one side of the equation and manipulate it to look like the other, but I didn't do that. This one, though, is worth 4 points. So the last problem says find the equation of the line that contains the center of the two circles. So we need to figure out what the center of these two circles are, and they're not in the form that we can tell what the center is, so we need to rewrite them in the form, the standard form of a circle, so we can figure out what that center is. So let's regroup our x terms together. For the first circle, x squared minus 4x. I'm going to add something in here to make it a perfect square. So I'm going to leave some room. And then we have plus y squared plus 6y. We're going to add something in here to make it a perfect square. This is equal to, we want to get the constant to the other side, so subtract 4 on both sides, so we have negative 4. We're going to add something to make the x terms a perfect square, so we're going to do that also on the right hand side. If you do it to one side, you add it to the other, and then plus. Adding something to the y terms to make that a perfect square. So to make it a perfect square, you're looking at half of your b value, which is negative 2 in our case. And so negative 2 plus negative 2 is negative 4, and those two numbers we multiply together. Negative 2 times negative 2, this is positive 4. So we want to add 4 to our x terms to make that a perfect square. Same sort of idea for the y terms. We're looking at half of our b value of our y terms, and so half of 6 is 3. And so the constant that we need to add to make that a perfect square is 3 times 3, which is 9. So let's add 9 to both sides of our equation. X squared minus 4x plus 4 is a perfect square. This is x minus 2 quantity squared. Plus y squared plus 6y plus 9 we can rewrite as a perfect square, and that's y plus 3 quantity squared equals negative 4 plus 4 cancels, plus 9, so that's 9. So we have a center at 2, negative 3. Okay, so we have 1 point on that line that goes through this center. And so we want to look at the center of our second equation. So I'm going to rewrite it, and I'm going to rewrite it grouping our x terms together and our y terms together, leaving us room to rewrite that as a perfect square. So we have x squared plus 6x. We're going to add something again to make this a perfect square. We can just do it now. Half of 6 is 3. 3 squared is 9. Rewriting our y terms together. So for second equation of the circle, we have x squared plus 4y plus, so we're looking at half of 4 and squaring it gives us 4. Getting our constant on the other side, so we subtract 9 on both sides. But on the left we added 9 and we added 4 to make those perfect squares over here. And so our first perfect square, x squared plus 6x plus 9, is x plus 3, quantity squared, plus y squared plus 4y plus 4, that is y plus 2, quantity squared, equals, well, the 9's cancel and we're just left with 4 on the right-hand side. And so in this case, we can see that our center, HK, opposite signs, -3, -2. So we want to find an equation of the line. We need two things. We need a point, well, we have 2 of them, and we need the slope. And with the 2 points, we can find our slope of the line. And so our slope is our change in y. So let's look at -3 minus, point on the bottom, -2, all over the center. The first center we found was 2 minus the second center, which was -3. So -3 plus 2 is -1, all over 2 plus 3, which is 5. So we have a slope of -1/5. And we want to use one of our points to find the equation of the line. I'm just going to use my first point, and I'm just going to plug this into y equals mx plus b. And so if we do that, our y value is -3 equals our slope, -1/5, times x, which is 2, plus b. So I get -3 equals -2/5 plus b. Getting b by itself, I would add 2/5 to both sides, but I'm going to need a common denominator with this -3, which will be, common denominator will be 5. So that -3 I could rewrite as -15/5. So my b value is going to be -13/5. So my equation of the line there that joins those two is y equals my slope, -1/5, times x, plus b, which is -13/5. So that's one form that you could have written it in. You might have used your point slope form, so it might not look quite like that. You might have put this in standard form where you cleared your fractions and got the variables to one side and the constant on the other. All of those would be fine as your solution. And this is worth 12 points. So that is your exam. I want you to go through, and I want you to go back and sum up all the points that you got on each part. And then you're going to go back to the top of the first page and put your grade in here that you got. This was out of 100 points. And now you're going to go and you're going to upload this to an assignment that I created in Canvas for your graded version of your first exam. So hopefully that was helpful and you found out and understood what you did wrong if you got a problem wrong.